Voyager II is one of the greatest marvels of space exploration. The spunky spacecraft is still moving strong, despite having existed for more than 4 decades. Its discoveries still amaze the world's scientific community, not minding that it is now separated from us by billions of miles. One of the most jaw-dropping is the most recent discovery in images that left the entire space industry shocked. What are the discoveries of Voyager II in deep space? What do these discoveries mean for the future of the space industry? And how do these discoveries have an effect on you personally? What is seen out there? When we say out there, we mean the deepest part of space. Are there aliens there? Or are civilizations making progress in technology as we are doing? Are they striving to establish contact with us as we are striving to do with them? For the past 40 years and even more, Voyager II spacecraft has been on the mission to find answers to these questions, and what it has found is nothing short of intriguing and enlightening. It brings to our remembrance that a lot still lie to be explored. During the preparation of the 2 Voyagers for their mission, the engineers and the scientists did not think that they would last this long, but it turns out that the 2 spacecraft are breaking records every day. In actual sense, the Voyagers were built to last for just 5 years and conduct a close-up study of Jupiter and Saturn. As the mission continued, however, Voyager II completed additional flybys and exploration of the 2 most extreme giant planets, Uranus and Neptune. The Voyager II is fitted with various instruments that help it understand its environment, including ISS, Imagining Science System, Ultraviolet Spectrometer, UVS, Infrared Interferometer Spectrometer, IRIS, Planetary Radio Astronomy Experiment, PRA, Light Polarimeter, PPS, Triaxial Fluxgate Magnetometer, MAG, Plasma Spectrometer, PLS, Low Energy Charged Particle Experiment, LECP, Plasma Wave Experiment, PWS, Cosmic Ray Telescope, CRS, and Radio Science System, RSS. But what exactly is it that has kept the Voyager II spacecraft active for so long? Well, the reason for this is that the Voyager has left behind a long-lasting power source, and this is why it can still send and receive signals from control stations and still be able to have the energy to take readings of its environment. The Voyager II does not derive its power supply from solar energy because the part of space where the Voyager is currently located is far beyond the reach of the Sun. It instead depends on radioisotope thermoelectric generators, RTGs, for its energy, which is the major energy they still function. The spacecraft has 3 RTGs that use plutonium-238 as fuel, and isotopic decay uses the heat produced to convert it into electrical energy. At takeoff, Voyager II had the capacity of generating 470 watts of power at 30 VCD, but over the years, that capacity has been waning. The thermocouples used in the system have also degraded over time as the fuel runs out. Engineers said that as of 2011, Voyager II was producing just under 270 watts, or about 76% of its original output which it started off with. But that is still sufficient to fly a spacecraft across the solar system. There is another reason why the Voyager II is still functional. The reason is that it keeps receiving updates at all times. As Voyager II flew through the solar system, managers made use of remote control to reprogram it, making it have higher capabilities than it did when it left Earth, thereby allowing them to change its itinerary as required. In addition, the equipment that receives the signals on Earth has been modified to ensure they can handle communications over large distances. So, where is Voyager II right now? Of course, its position is never constant as it travels through space at a great speed, but just like its twin, Voyager II has left the heliosphere. This does not in any way mean that Voyager II has left the solar system. It may not even get to leave the solar system because of the boundaries of the solar system are believed to extend beyond the Oort cloud, which is a group of little objects that are still affected by the gravity of the Sun. No one knows what the width of the Oort cloud is, but astronomers believe it extends from about 1,000 AU from the Sun and even extends to about 100,000 AU at the very edge. 1 AU is the distance from between the Sun and the Earth. With the rate at which it is moving, it would take Voyager II about 300 years to reach the inner edge of the Oort cloud, and possibly 30,000 years to fly out of the Oort cloud in the end. If the lifetime of Voyager II is divided into chapters, Chapter 1 will be Jupiter. It was Voyager II's first stop, which was appreciated only 2 years after it was launched. It explored the gas giant and its magnetosphere and studied its moons in more detail than Pioneer did. Voyager II has sent us unbelievable pictures of the entire Jupiter system, and a time-lapse movie made from the images of Jupiter shows how Jupiter has changed since the visit of Voyager I. The spacecraft also studied the Great Red Spot, the largest storm in the solar system, and also discovered the 14th moon of Jupiter we know of today. Chapter 2 is Saturn, which Voyager II arrived at in 1982. Being that it carried a photometer, Voyager II was also able to observe the planet's rings at a higher resolution, which led to the discovery of more rings. It also offers more detailed images of the ring spokes and knots, the F-ring, and its shepherd satellites. The third chapter is Uranus. Voyager II was the first and only spacecraft to visit Uranus in 1986, where it found evidence of an ocean of boiling water about 800 kilometers or 500 miles below its cloud tops. It also discovered 10 new moons, a pair of rings, and a strangely tilted magnetic field stronger than Saturn on Uranus. The spacecraft also witnessed the planet's 98 degrees tilt, which shows it is basically spinning on one side. The fourth chapter is Neptune. Neptune has never been visited by other man-made objects before, and Voyager II flew about 5,000 kilometers or 3,100 miles above the planet, where it discovered 5 moons and the large black spot that no longer exists. It was also confirmed by Voyager II that Triton, Neptune's largest moon, is the coldest planetary body in the solar system. Voyager II opened a new chapter in August 2007 when it reached the heliosphere, then entered the heliosheath. As of November 2017, the spacecraft was at 116.167 AU from Earth, or about 17.378 billion kilometers. It was moving at a velocity of 9.6 miles per second, or 15.4 kilometers per second, heading in the direction of the other constellations. Voyager 1 left the heliosphere 6 years earlier, and in 2018, Voyager 2 followed suit. The heliosphere is the protective bubble of particles, radiation, and magnetic fields produced by the Sun. Some of the discoveries were no different from what Voyager 1 saw, even though they are headed in different directions. Here, Voyager 2 measured a jump in particle density, which was accompanied by a sharp decrease in particle velocity and a shift in the magnetic field. In this part of the solar system, however, there are some differences in data that provide clues to complex dynamics. The Sun spews a continuous stream of particles called the solar wind in every direction, which travels at an unreal speed of 1,000,000 miles per hour. The particles, which are mostly hydrogen, split into protons and electrons when heated to about 3 million degrees Fahrenheit. At a distance of more than 11 billion miles from the Sun, the solar wind gets thinner, and Voyager 2 is being blasted by the flow of particles in the interstellar wind and the galactic magnetic field created by the explosion of distant stars long ago. Interstellar winds are much cooler and denser. As it approached the boundary, Voyager 2 discovered that the outward velocity of the solar wind dropped to 0 long before it actually reached the boundary, because it was pushed sideways. As the solar wind slows, the particle density increases and the magnetic field strengthens. So, what will happen when the energy in the Voyager 2 finishes? Well, not yet, but we will certainly get there one day. Prior to that, scientists have turned off some features on the 2 Voyagers to save energy. However, scientists are already planning an alternative mission using everything they've learned from Voyager. The new spacecraft will fly faster than Voyager and thus reach the heliosphere faster. Such a probe would first head to Jupiter, using the giant planet's gravitational acceleration toward the Sun. As it orbits the Sun, the spacecraft will fire off a rocket motor that accelerates to speeds that can travel nearly 2 billion miles a year. That would be more than 5 times the speed of the Voyager. So, what do you think about Voyager 2? Let's hear it in the comment section.